Let's dive right in. Today, we're taking a look at a real university syllabus for a web programming course. And you might be thinking, a syllabus? But trust me, this is like the secret roadmap, the blueprint, that shows exactly how a modern website gets built, from just an idea all the way to a full-blown application. I mean, have you ever been scrolling through a site and just stopped and thought, how in the world does this actually work? There's just so much technology humming away behind the scenes. Well, using this syllabus as our guide, we are going to pull back that curtain and see exactly how it's all put together. So, to make sense of all this, we're not just going to think about writing code. Instead, let's imagine we're on a digital construction project. We are building something complex from the ground up. And this syllabus? Well, that's our official blueprint. And just like a real architect's plan, a syllabus lays everything out in a super logical order. It tells you what you need to build first, the foundation, and then shows how every new piece stacks right on top of the last, all the way up to the final polished product. Now, these are taken straight from the syllabus, but don't think of them as boring course objectives. Think of these as the actual power tools you're adding to your toolkit. You're not just learning theory, you're learning how to design, how to apply new techniques, how to create connections, and at the end of the day, how to build a whole application. It's all about practical skills. All right, so every construction project has to start somewhere. For us, we're starting with the part everyone sees and interacts with first, the user experience. This is the facade of our digital building. It's the look, the feel, the windows, the doors. The technical term for this is client-side programming, and all that means is that the client is you, or more specifically, it's your web browser. All the code that makes a website look and feel a certain way is actually downloaded and run right there on your own computer. This right here is probably one of the most fundamental concepts in all of web development. You've got the client side, that's what you see, what you click, and then you have the server side. That's the powerful brain running on some remote computer doing all the heavy lifting. Our syllabus starts with the client side, which makes total sense. You got to build the storefront before you can wire up the warehouse, right? So how do we build that client-side experience? Well, the syllabus points to 3 essential technologies. And the easiest way to think about them is like building a house. First, you have HTML, which is the raw structure, the studs, the beams, the skeleton. Then CSS comes in. That's the paint, the wallpaper, the furniture. It makes it all look good. And finally, you have JavaScript. That's the electricity and the plumbing. It makes the doors open, the lights turn on. It brings the whole house to life. Okay, so we've got a beautiful storefront. It looks amazing, but right now it's just an empty building. It's useless without its engine room, the power and logic that makes everything actually function. So now we're going behind the curtain to the server side. And the language this particular blueprint chooses for the engine room is Java. The syllabus picks it because it's what's called an object-oriented language. All that really means is that it's fantastic for building really big, really complex systems in a way that's neat and organized. It's perfect for a serious web application. So why Java specifically? Well, the syllabus points out a few key things. Object-oriented programming helps keep huge projects from becoming a tangled mess. Exception handling is just a fancy way of saying it's really good at dealing with errors so your whole site doesn't crash. And multi-threaded programming means the server can handle requests from thousands of users all at the same time. These aren't just buzzwords, they're the features that make an app reliable and powerful. Okay, so Java is the language, but what's doing the actual work? That's where these things called servlets come in. The best way to think of them is as the managers inside the engine room. When your browser sends a request like, hey, log me in, a servlet grabs that request, figures out what to do, and sends a custom response right back to you. So, let's recap. We've got a beautiful front end and a powerful back-end engine, but we're missing something absolutely crucial: information. I mean, a social media site with no posts or an online store with no products, it's just an empty shell. We need to connect our engine to its data storage. So how does our Java engine talk to the database where all the information lives? The answer is something called JDBC, which stands for Java Database Connectivity. And really, it just acts as a universal translator. It doesn't care what kind of database you have. JDBC provides a standard, consistent way for your application to ask for data, update data, and manage it all. And you can almost picture that conversation happening, right? The application, using JDBC, sends a clear request. Hey, does a user named Alex exist? The database understands and sends back a clear answer. Yep, their ID is 42. It's this constant, structured back and forth that makes a dynamic website actually work.
Now, it's not just about talking to its own database. Our application also has to communicate across the whole internet, and this is done using something called sockets. You can think of sockets as the basic phone lines of the internet. They allow any two programs anywhere on Earth to open up a connection and start talking to each other.
All right, we are so close. We've built the structure, we've powered up the engine, we've connected all the data. The final step in our construction project is deployment. This is all about packaging our application up and opening the doors to the public.
A big part of deployment is being able to share data with other systems, and that's where the syllabus brings in XML. Now, don't mix this up with HTML. HTML tells a web browser how to display something, make this text bold, put that image here. XML is different. It describes what the information actually is. This isn't a headline, it's a product name. This isn't just a number, it's a price. This makes it perfect for computers to share data with each other. And that brings us to the final piece of the whole blueprint: web services. Think of these as a combination of a public contract and a phone book for applications. They provide a standard way for our brand new program to automatically find and talk to other services on the internet. Maybe to process a credit card payment or fetch the latest weather forecast. This is what makes the modern web so powerful and interconnected.
And it all comes back to that one key goal from the syllabus: to actually build something. After all the bits and pieces, the client side, the server side, the databases, the web services, the one single goal is to put it all together, to transform some code into a real, working, data-driven system. So there you have it, a complete blueprint for building a modern web application, all taken from a single course syllabus. We've seen the foundation, the engine room, and the final coat of paint. The only question left is, now that you've seen the blueprint, what are you going to build first?